Mueller's method here, and we are given a function of x equals e raised to 0.3x minus e raised to negative 0.6x minus 2, and we are asked to conduct two iterations. We are given x04, x16, x25, and we have our table here, and we are going to fill that up for the functions later. So let's get started. The very first thing we want to do is to find the functions of x's given our x0, x1, and x2. So we have and we write that down on our table. So we have fxi equals 1.2293, and our fxi plus 1 equals 4.0223, and our fxi plus 2 is equal to 2.4319, and we are going to find the values of a, b, and c. To do so, we have to first find the values of ho, hi, delta o, delta I to get our abc, and then we get our x3. So let's get started. Now we can get the values of a, b, and c because we are given the ho, hi, delta o, delta I. So for a we have negative 0.0646, and for our b we have (1.655). We write those down on our table and we continue our work. And now we get the xi plus 3. To do so, we first substitute these letters to our formula of quadratic formula to be able to determine whether we are going to use the plus or the minus sign in finding our x3. And we have determined that the plus sign is greater than the negative sign, so we are going to use that in our x3. So we have 5 plus negative 2 times 2.4319 all over 1.655 plus 1.8351, and then we get x3 equals 3.6064, and we are going to put that down on our table for our iteration 1. And then we proceed to iteration 2, and we're going to find all of the f of x's and our a, b, c, and then our x3. So we therefore only move one x. So we have 4.0223 as our xi and our 2.4319 as our xi plus 1. So we are going to determine xi plus 2. So we simply substitute our xi plus 3 to our function, and we have our new xi plus 2. So we have solved for our ho, hi, delta o, delta I a while ago, so we are going to solve now for our a, b, and c. This is very easy because we are only substituting them, and by substituting I mean direct substituting to our formula, no hassle. Once again, we have proven that the positive sign is greater than the negative sign, so we are going to use that in finding our x3. And we have 2.3133, and we are going to put those down on our table. Then we compute for our approximation error for our first and second iteration, and then we have 38.64% and 13.23%. We can see that we are decreasing. That's Muller's method.